Go. Hey, my name is Richard, and today we're just going to look at how to build a simple application using OpenAI's API. We're going to translate a document or a text or an article or whatever it might be, or a book or you name it, and we're going to input this text. We're going to split it up into these different segments, as you can see here, and we will translate each of those individual segments, and we will then recombine the text. That's what we're going to do. That's the aim. And the reason we even split it up, for people who are new to working with LLMs or just like understanding, just using them in general, you'll realize that LLMs actually have a limit in terms of how much you can load into them in one go. And to be honest, they usually have some form of a limit in terms of how much you would expect back as well. And so what you don't want to do is try and overload it. And so the best way to do that is just to split up a text. And so the way we're going to do that is we're going to start off in VS Code. And then in VS Code, we are going to, let's create a new folder. We'll create a new folder. Actually, do you know what? Let's just go straight in. We'll go into Jupyter Notebook. We'll go into Jupyter Notebook. And so what will happen is we'll get Jupyter Notebook come up, and within here, we'll just be able to click new folder and set up a new folder. Really easy. And we'll just call this translation example, for example. And then within here, we'll just start up a new notebook. And we can just rename that directly in here and call it translate. So now we have this new notebook, translate, sitting in our folder, and we can start to work with it. And so first thing first, and just title this. So we'll call it, and just shortcut, you can use M just to try to convert everything to Markdown. So translate notebook, and we'll say that the purpose of this, purpose to translate input text from one language to another, right? That is what we are trying to accomplish here. And we can just set that aside like that. And now what we want to do is we want to set up first like the configuration. I think that's probably the first thing to set up, and we can use that just to kind of guide what kind of flexibility or functionality you want to have in this. And so several things that we want to put in. First, we want to have for sure an input language. You technically don't need it because it can just auto detect, but an input language is useful. We will also have an output language, and that will be, let's say, French. And then we will have an input data path. And so we might just have that as, for example, data. So the current directory, but then go data.input.txt. That might be what we're looking at. And in order to set that up, we can just, on that note, we can go to here, we can add another new folder, and we can just call that data, like we just said, and we can add a new file and call that input.txt. So this we now have the Jupyter Notebook that we're working in, and we have this input.txt. Now, what do we want to, input will just be what we want to translate. And for the sake of demonstration, what I've done is Oliver Twist is on the public domain, and so I've just gone to grab that, and we can just translate the first chapter, right? So everything down to here, we can copy and paste that directly in, and voila. Right now we have some nice text that we can translate. Next steps is to now sort out our dependencies. So what do we need to actually run this code? And that can be, if we start off with, let's do dependencies, and we can, there's two key dependencies that we want to install. We want tick token, and we also want OpenAI's APIs, and we can just run that. And that seems to be coming out fine. Okay, cool. Next step is we will then maybe import the packages. So import OpenAI and tick token, and we will then also import the data file. So input that open the input path, and we want to read that as f, and we'll just set text equals f.read. So that will give us what we need, and we can see that that's come through because we can just say length, not lean, length of text is 6,263. Perfect. So we can section that off. And now next thing we really want to do is we want to start counting the tokens. We want to be counting the tokens, right? So tokens cost money, so you want to make sure that you're not overspending. You also want to kind of be able to predict to some extent how much you're going to spend. And so the way to do that is we can leverage tick token. So tick token is OpenAI's tokenizer. We use tick token to break up these sentences, these paragraphs, these chapters into small sections of a word. They are then mapped to numbers. Once we've essentially encoded the text accordingly, we will then have the text broken into tokens, what we call tokens, and we can just essentially assess the length of the tokens to figure out what exactly it is this will cost us. And so, for example, we can do that here just with this little segment of code, and we're using the GPT 3.5 model as a point of reference, and this will give us this will tell us how expensive this whole operation will be in terms of tokens. And so if we did input token count, we can see it's actually going to be 1,407 tokens. It's about a quarter, which is expected. So that's roughly how much you should expect it to cost you as far as tokens are concerned. Now, I'm going to say here's the fun part. The next part we need to do is we need to segment the file, right? And so we need to split up the file using some sort of split string. Maybe to be consistent, let's just add in another section here. Yeah, we need to segment the file using a split string. And so in this case, we need to go back up to the top and we need to add a split string. And it's the string that we want to use to split up the file. And so if we split it up by sentences, it would just be full stop. If we want to split it up by paragraphs, maybe it will be \n/n. So whenever there's two new lines, and that would be sufficient. So we rerun that. So we've got split string implemented, and now we can do split text equals text.split. So we're splitting up the text that we've read in, and we're gonna split that up using split string, right? And that now we can, and we'll be able to check that. So split text. If we take the first one, we can see it actually split the text accordingly. And if we take number 2 and number 3, it's 0 indexed, so I'm always one behind. We can see that it's actually split up accordingly, which is good. That's what we want. And we can check how many there are by doing length on this. And we can see there are 19 segments in this entire string. Next thing that we want to do is we want to see the longest segment. So we want to see what's the maximum number of tokens potentially that's being put through. To do that would just be longest segment equals max. Well, I don't even need to store it as a variable. We can just do longest segment. Well, we can just do max split text key equals len. Right. So this is the longest segment, and if we wanted to get the length of that, we just put length around that. And we will see that the longest is 1,547, and we know that roughly it's divided by 4, which is 386.75. So it's going to be about circa 400 tokens to put the whole thing through, which is fine. That's nothing crazy. OpenAI's LLMs take about 4,000 plus tokens, and so this is not even up to a tenth of that. So that's perfectly fine. We could have probably put through a lot more. And so the next thing that we want to do is we want to write the system prompt. So if we set that off again, and yeah, if we start, so we can say system prompt equals f, and now we want to say this is the prompt that we're going to give the system. So this is exclusive to OpenAI in terms of system prompts, but the principle applies to just general messages as well. We want to tell the LLM exactly what to do. in the clearest terms. And so firstly, we'll just say, you know what, you are a translation tool. You're a tool. That's what I want you to be, a translation tool. And you receive a string written in, and so firstly, we're just going to tell it, you know, you're receiving a string and it's written in I before E except after C, things you learn at school. And we want it to be written in input language, right? Input language. And we say, and we want it to return, so, and solely return, return the same string in output language. So we want it to return the same string in output language. This is the nice thing about working with LLMs as well. You can speak in English and in natural language, and it understands you. And it's just a different type of engineering altogether in that respect, but it's still just engineering. And you want to do this without losing any of the original formatting. And like, if we're going to be like really pedantic, we can add like some extra like instruction there just to make sure that it's all really precise. So we can be like, your translations should be accurate, for starters, aiming not to deviate from the original structure, content, writing style, or tone, or even and tone. Better. Now we have our system prompt. So if we do system prompt, there we go. So yeah, you are a translation tool. You receive a string written in English and solely return the same string in French without losing any of the original formatting. Your translation should be accurate, aiming not to deviate from the original structure, content, writing style, and tone. That is the clearest message you could ever give. Now we can actually work through just the segmenting and the looping, etc. And that should be relatively straightforward. And so I'm just going to paste in this code. And yeah, this kind of I'll walk through this just really quickly. But what this is doing, it's nothing too complicated, is we have a results array that we're initializing, and we have counter and tokens consumed, and these are just variables that will be incremented over the course of the looping. Then we have split text, which is the text that we've already split up, right, after we've used the split string to split it up, just to show that. So split text is like this. So for each text in split text, so if we take the first one out, it will be for each of these, right, for each of these, that being the first one and that being the second one, and that being the third one, etc., right? It will go through each of the sections and it will apply this code. And first thing we'll do is say, okay, to the system prompt, that's what we were creating up here. The content of the system prompt is what we've just had here. So you're a translation tool, etc., right? And then the second message in that is from the user, and the content of that message is the thing that we're translating. So we've already told it it's a tool in the system prompt. So then the next thing that and that it needs to translate stuff, everything that we give it, and now in the next message, we give it the thing that we want it to translate. That's all that's happening. And that's the set of messages that we're passing into the language model. Thereafter, all we have to do is create the model parameters, which is the model itself that we want to use, which is GPT 3.5. 4 is more accurate, but 3.5 is very, very good and sufficient for our purposes. Then we'll feed it the messages, and then we will, that we just specified up here, and then temperature 1.0, which is standard, and probably the default value anyway, but I thought to include it nevertheless. And then, yeah, after that, we've just got some basic retry logic. So maximum number of temps, retry gap, that kind of stuff. We could have put it up in the config, but it's nothing major. So we're just telling it to try until it fails, until it's hit the attempt limit, or until it passes, then we'll break. If it fails, then we'll print the error and try again in a few seconds. But yeah, it will go through, provide the model parameters. So we're just, this start, all we're doing is unpacking the dictionary value. That's all it's doing. So it's just feeding these parameters in a separate variable. So model as GPT 3.5 and messages as messages and temperature as temperature, as opposed to as one single object. And then it will append the results. We're just extracting out the results when we're deconstructing here. So within choices, the first value, message, content, we actually get the results from this, and we're just appending it to results. And the tokens will just, again, figure out how many tokens were used, and we're just going to add that on. And then the counter we increment, and then we say, okay, now that we've got the results in the array, we've checked how many tokens, we've incremented the tokens, or we've aggregated the tokens, so we know how many tokens we've got. So that's just the cumulative value. And then we've incremented the counter by 1. We then say that we've completed section X, or section counter, out of the total number of sections. That's all we're doing. And then we try again and again and again and again. And so it's nothing too crazy. And if we just set that to run, it will take a few seconds per section. So what I will be doing is going out, saying hi to the kids. They've just come back from the library. And then after I finish talking to them, this should be done. Okay, just checking how far along we have got. And it's done. Perfect. And the kids made some cake. Amazing. All right then, cake done. Okay, so now we should have the translated text. And so we can check that. So if we do results, and this will still be in array format at the moment. So we can see now that actually it has translated it in line with expectations. Funny enough, if we go to print on that, it will put it into, without all of the backslashes and stuff like that, the escape characters, it will just have the translated text perfectly. And we can check how that is done, and it's great. It looks good. Okay, so final step now is to bring together all of the split up text into a single string, as opposed to an array. And so in order to do that, we can just do final results equals, and we'll take the original split string, so split string dot join, and we can just do that on results. Now if we again final results, it will come out with like all the backslash characters and stuff like that. And so if we just print that, we will get the results in the format that we expect. So perfect. And as for tokens consumed, you would expect that to be roughly whatever the inputs were, the input token count was, which was 1,407, and then it's just, you're translating it, so it's just double that, which is 2,800. But then there's also the added system prompt. The system prompt is done 19 times. The system prompt is done 19 times, and it's really however long that system prompt is. And so if we expect that system prompt to be, we can just do this to be fair. System prompt is 53. So system prompt, so that times 19 will be 1007. So you'd expect it to be roughly, obviously the new language is slightly different, but you'd expect it all roughly to come up to about, so we can just, so that's 1000, and that was that. There we go. So you'd expect it to be roughly 1,400 times 2 plus another 1,000. So you're looking at about 4,000 tokens, maybe just a bit more if French is a bit more verbose. And so yeah, so if we do, to check that, we can literally just do what tokens consumed, because we were incrementing that before. If you remember up here, we were just adding it on each time. And so tokens consumed equals 4,005, right? So yeah, just over 4,000. Not too bad. And that's a nice way to kind of guesstimate things and keep things under control if you are building up an application generally. But yeah, this is it. This is how you would translate a text from one language to another, using OpenAI's LLMs. If that's helpful, then definitely please like, share, subscribe. I've also included this code on GitHub with more annotations and stuff, and so hopefully that's useful, and I'll include that in the links below. And if there's anything else you guys want to see as far as code-wise is concerned, I'm looking to produce a few more videos. But if there's anything in particular you guys want to see me build, then I can do that for you. But yeah, the support is appreciated. Cheers, and hopefully we'll be back soon. Cool.